Today we are covering 5.3. We are multiplying and dividing monomials, negative exponents, and your homework is page 215, 1 through 77 odd. Try the challenge problems. So we're continuing to work more with the rule of exponents. All right, so first let's talk about what is a monomial. A monomial is one term. Okay, mono means one as opposed to poly, single term. Please make sure you write this down. You're going to need the language. I'm going to be using it quite a bit. So it's a single term, a group of numbers or variables tied together by multiplication. Okay, tied together by multiplication or division and separated by addition and subtraction. So let's look at monomials. Okay, so this is a monomial because it's tied together by multiplication, negative 5 and x. 3x squared y, that's one monomial, one term. It's tied together, numbers and variables tied together by multiplication. Remember, next to means multiplication. 4/3 a squared is a monomial because it's all tied together by multiplication. This is a monomial, and it is tied together by multiplication and division. It's one term. Now, we start to know it's no longer a monomial when you start to see, let's say if I added a plus sign here, here's a monomial and here's a monomial. A monomial is numbers and or variables tied together by multiplication, but separated by addition and subtraction. So as soon as you see two terms, 3x squared y is a monomial, but as soon as you see the minus 2/3 x to the fourth, that now is no longer a monomial. It's a binomial or polynomial. Bi means 2, poly means 1. Okay? So, a monomial is one term made up of variables and coefficients. Okay? Oops. Sorry. Okay, the coefficient is the number that comes before the variable in a variable term. So, take a guess at what the coefficient is in the first term. That would be negative 5. The sign goes with it. In the second term, the coefficient is 3. The third term, the coefficient is 4/3. The fourth term, look at this, the coefficient is negative 5/2. And believe it or not, this last term has a coefficient, and that is 1. Okay? So the coefficient is the number that comes before the term, precedes the term. All right, state whether the following is a monomial or not. Okay, pause your recording and finish these up. Okay. Pause the recording. Okay, let's check our answers. So number 1 is a monomial because it's one term. It's numbers and or variable. Number 2 is not a monomial because there are two terms separated by a is one, 5 is the other. Once you start separating by plus or minus, you get into more terms. Okay, number 3 is a monomial. Number 4 is a monomial. Number 5 is a monomial. Number 6 is not a monomial. Number 7 is a monomial because it's one or, it's variables and or. And number 8 is not a monomial. And let me go back. Let me just do this. Let's go right here and Google a monomial. You'll see what the true definition. Well, it's not a great. I've seen better definitions. Well, it has to be a whole number, and because that's really I don't know, let's see. Also okay. Is the product of powers of variables with non-negative integer exponents, or in other words, a product of a variable possibly with repetitions. I don't know, I'm not seeing a great one. We'll get to another one here. But when we go back to our PowerPoint, this is basically, you haven't learned about these yet, and we will get into them. This is it is a cube root squared. It's something like that. So we'll just have to explain that later as it comes to us. Okay, going back to the slideshow. Let's go to... So, now when we're multiplying monomial by monomial, it's kind of a review of what we've already done. We multiply coefficients like normal. Okay, coefficient with coefficient, like base with like base. So I'm just rearranging things. The coefficients, and when the exponent is not inside and outside, they're both inside the parenthesis, then we're adding the exponents. Okay? So 3 times negative 2 is 6. The coefficients are normal. And a to the second power plus the second power is a to the fourth power. All right, pause the recording and try the next 3 on your own. Now, one hint. Remember, if there's no exponent there, there really is an exponent. And if there's no coefficient, there really is a coefficient. Okay. Now let's check our work. We're multiplying here. 3 times 5, and x to the 3 times 5, and x to the first plus the fourth. So it's 15, x to the fifth. Next one, this is to the 1, and this is a 1 power. So I've got negative 4 times 3 times negative 1, m to the second plus the fourth plus the first. So we get positive 12, m to the 7th. Last one. Remember that a is to the first, the c is to the first, and b is to the first. So I'm going to do 7 times 3, a to the first plus the fourth, b to the second plus the first, c to the first plus the third. That makes 21, a to the fifth, b to the third, c to the fourth. There we go. Did I not do this one down here? Okay. All right, so now we're putting it together. Okay. First we do power to a power. Remember, that's when we multiply our exponents. So 5 is squared, y to the third times 2. And on the next one, I get negative 2 is squared, y to the second times the second. Okay, I'm going to simplify. It's 25, y to the 6th, times 4, negative is squared, y to the 4th. So first we do the power to the power. Then we simplify. Okay, number 2. Number 3, now we're using our rules of exponents. Here we multiply the exponents. Here, when there's no inside-outside parentheses, we really add the exponents. So, and multiply the coefficients. Okay, so I'm doing 25 and 4 is 100. And y to the 6 plus the 4th makes 100 y to the 10th. Okay. Let's do this. Let's make this 25 times 4 times y to the 6th. There we go. Now you try the next one. Pause your recording. All right, let's check our work. So we're first taking the power to the power, so I'm doing 3 squared c squared times negative 2 to the 3rd and c to the 4th times the 3rd. That makes 9c squared times negative 8 c to the 12th. So now we're multiplying 9 times negative 8 and c to the 2nd plus the 12th. So it's negative 72 c to the 14th. Okay, we do our power to a power here. We're simplifying. And then we use our rule of exponents, rule of multiplying exponents. Okay. We're just multiplying monomials. If we have negative exponents, we still can follow the same rules. So let's just look at it right here. Notice over here we're adding the exponents, over here we add the exponents, over here we subtract the exponents. If you have a negative number, you can do that too. So 4 plus negative 2, right? And this would be 7 to the negative 2 minus 3. So there's multiple ways to do it. Let me show you. I think it'll be better if we just move on instead of look at rules. Okay. So there's 2 ways to do it. You can take the reciprocal. The other way is we can reciprocate it right away. 1 over 7 to the 2 divided by 7 to the 3rd. Then it becomes times 1 over 7 to the 3rd. That makes, so, oops, I'm on writing mode. Okay. I like to, whenever I have negative exponents, there's 2 ways to do it. We can do this. Remember, when we divide, we subtract. So I have x to the 5th power minus, and then I have a negative 4. So that's method number 1. That 2 negatives make a positive, and so that's x to the 9th. Another way we can do it, because if my fraction is bigger, right away, all I'm going to do is if I have a negative exponent, I'm going to take its reciprocal. I can rewrite it as x to the 5th, move this up, and make it x to the 4th. And that's x to the 5th plus the 4th, which is x to the 9th. Okay? So try number 2. You have 2 ways to do it. You can take the reciprocal of the negative exponent and then do the rule, Or, all right, let's try it. So this one seems easy enough. I'll do it both ways. I can do y to the fourth plus the negative 3. 4 plus negative 3, y to the first. It's y. Or I can drop it right away to the reciprocal. Y to the fourth times 1 over y to the third. Remember, when I have a negative exponent, it's really a fractional amount. What that really means is y to the fourth over y to the third. I can take 3 out here and 3 out here, and I'm left with y to the first over 1. It's y to the first. Okay? Okay, they're going to get more complicated, and that's why I always like to have you think about first. I like to take the reciprocal first and rewrite it without the negative exponents. Okay, so let's try these. I know that you guys have had some practice, so try number 1. Go. All right, let's check it. Now, again, you can do a to the 10th minus the third, but once we start adding more variables, that gets confusing. I'm going to take 3 a's out here, and I'm left with 1. I'm dividing 7, 8, 10 a's, 3 a's here, and I'm left with a to the 7th, which is a to the 7th. I could have also written that like this. To the 10 minus 3. Okay? Okay, next. I have coefficients, so we're going to divide common factors. If I divide 2 out of here, I'm left with 1. If I divide 2 out of here, I'm left with 4. The greatest amount of x's we can take out is 4, so I'm left with 1. And when I take 4 out here, I'm left with x to the 5th. So I multiply across, I get 4x to the 5th all over 1, which is 4x to the 5th, simplifying. I would have just gone right to this answer. Okay, pause the recording and try number 3 on your own. Go. So, 3 goes into 6 3 times, and 3 goes into 9 2 times for the numerator. Now, greatest amount of m's we can take out is m to the 4th, and I'm left with 1. When I take out 4 here, I'm left with m to the 8th. So multiplying across, I get 2 over 3m to the 8th. All right, let's keep going. Pause the recording and try the next 3 on your own. Okay, we can take 3 out here, and I'm left with 1, and I can take 3 out here, and I'm left with x to the 5th. The greatest amount of 9's we can take, y's, is 9 of them. I'm left with 1. When I take 9 out here, I'm left with y to the 3rd. Multiply across, we get x to the 5th over y to the 3rd. Okay, next one, let's take out a 3, and I'm left with a 2 and a 1. I can take out 2 a's, and I'm left with a to the 5th. I can take out 4 b's, and I'm left with 1. So I'm left with 2a to the 5th over 1. I don't have to write over 1. Okay, remember this is to the first power. So, okay, so here we go. I'm going to take 2 out of the numerator. I'm left with 4. Sorry. 2 divides into both. I'm left with 5. I can take 4 w's out, and I'm left with 1, and I'm left with w to the 3rd. I can take 1x, and I'm left with 1, and I'm left with x squared. So, in the numerator, I'm left with 4 times 1 times 1, which is 4. In the denominator, I'm left with 5w to the 3rd, x squared. All right. so when we have our negative exponents, we're just using our rules of and we're doing power to a power with negative exponents. We're just doing the same thing, using the same. When it's inside outside, we multiply the exponents. So that really is a fractional amount. If I want to write it with positive exponents, I write it 1 over 2 to the 6th. Okay? All right. So here we're going to do 5 to the 4 times the negative 2, and that's 5 to the negative 8, which, gosh, I don't know what that is. Let's look at the PowerPoint to it. Okay. Oh, why did I get that? Negative 5 times negative 2. It's 5 plus negative 2. Sorry, I screwed that up. Because they're not outside, inside. So we just add, let me go back. So it's going to be 5 to the 4th plus negative 2. So 5 to the 4 plus negative 2 is 5 to the 4th minus 2, so it's 5 to the 2nd, which is 25. It seemed like that would be. Okay, so here we're going to get 8 to the negative 2, and that equals 1 over 8 squared, which is 1 over 64. Okay, you try it for the rest. Now we're putting it together. Now let's check our work. So I get 7 to the negative 6 times 7 to the 5th. Now, since they're out of the parentheses, I do my power to the power first. Now I'm doing 7 to the negative 6 plus the 5th. So it's 7 to the negative 1, which is 1 over 7. Okay? Let's try the next. I'm doing 3 squared. We can do 3 to the 2 plus negative 4. And remember, this one is to the first. So these bases are all the same, so I can do 2 plus negative 4 plus 1. So that really makes 3 to the 3rd minus 4. So it's 3 to the negative 1, which is 1 over 3. Okay? Now the next one, they're not common bases, so we just have to multiply them out. That would be 8 and 5 times 1 over 5 squared, which is 8 over 1, 8 over 25. Okay, now we have some more power to a power because of the... So I have 4 to the negative 3 times negative 2, and 4 to the negative 2 power. So that makes 4 to the 6th power times 4 to the negative 2. Would be 4 to the 6 plus negative 2, so it's 4 to the 4th. 4 times 16 times 16, it's 256. That's not 44, it's 4 to the 4th. 4 times 4 times 4 times 4. Okay? Okay, now, reminding you that when we have something like this, the base of that exponent is only what's touching the exponent. So 3 is not part of it, so 3 stays up. Create your fraction. 3 stays up, m squared moves down. Okay? What stays up, what goes down? 6 is not part of the base. The only thing touching the y to the second is the negative 2 is the y, so that drops down. Y to the second, 6x stay up. Now, what's touching here? Everything. So everything drops down. 6xy, and it goes to the positive 2 power. What comes up is the 1. This simplifies to 1 over 6 squared x squared y squared, which is 1 over 36 x squared y squared. Pause the recording and try the next three on your own. It's y to the 4th power plus negative 4. It's y to the 0 power, which equals 1. Anything to the 0 power equals 1. Right? I'm going to just remind you, whenever I have a plus negative, when you multiply them together, they make a negative. So it's 4 minus 4. Right? All right, let's try the next. 2 is to the negative 3rd power. X is to the negative 3rd power. Y to the 3rd times the negative 3rd power. So this becomes 1 over 2 to the 3rd times 1 over, drop it down, x to the 3rd times y, times y to the negative 9th, which is 1 over y to the 9th. So that becomes 1 over 8, 2 times 2 times 2, x to the 3rd, y to the 9th. Okay? And the last one, we have to do some power to the power. Everything in there is to the 2nd power. 2 is to the 2nd power, a to the negative 3 times the 2nd power. And b is to the negative 4th power. So this becomes a 4, a to the negative 6, b to the negative 4. So as I make my fraction, remember, negative exponents are really fractional amounts. 4 stays high because it's not part of the base. A to the 6th, b to the 4th. There we go. Sorry guys, a lot of practicing. Okay, what happens if we have a negative exponent in the denominator? We can just take the reciprocal. Move it up, take the positive power. Same thing, flip it and take the positive quantity. So this one moves up to 3 to the 4th times 1, and it becomes 3 to the 4th, which is 81. This is going to come up to y to the 3rd times x is x, y to the 3rd. Try the next two on your own. Okay, whole thing is coming up. 5a to the 2nd times 1. I don't need to write times 1, right? It's 5a to the 2nd. Oh, it's 5 to the 2nd, a to the 2nd. Sorry, should have had this. That means so that is 25a squared, and times that 1. Getting kind of sloppy here, sorry. So let me see what they're doing here. Let's go with their work. Okay. So we're just reciprocating those negative exponents and then doing our work. So before I do anything, I rewrite it. M stays on top. Okay, it's a perfect example. M stays on top, 7 stays below. X to the 3rd, because it's a negative exponent, I take the reciprocal and make the power positive. Y, take the positive. And there's no other simplifying to do, so that's a final answer. Okay. All right. This gets to be a little bit more complicated, and we're going to need to go over these, but I don't think it's in tonight's homework. But basically, I'm going to put it into the video. So, we have to simplify this, and then we have to simplify this, and then only if they're like terms can we add them together. So here I get 7 times 2 is 14. A is to the 1st. So a to the first plus the second is a to the third and b to the first. Minus 5a to the third, b to the first. Now, because these are like terms, a to the third, b to the first, all we have to do is we can add them. It's like saying 5 box of cards and minus, or 14 box of cards minus 5 box of cards is how many box of cards? 14 minus 5 is 9. Box of cards stands for a to the third, b to the 1. So only if the variables and exponents are exactly the same can you do that. Pause the recording and try number 2. Okay, we're going to do coefficient with coefficient, like base with like base. So I'm going to have negative 3. K is going to be to the 5th power, and x is 2, and 2 is to the 4th. Plus 5, k is to the 5th power, x is to the 4th. Now, these are like terms, so I can add them. I end up with negative 3, positive 5 makes positive 2, k to the 5th power, x to the 4th. Okay? You can try the next one. I'll put the answers up. Okay, here we go. Long PowerPoint. You should have had... There we go. Oh boy, this isn't good. So express using positive PowerPoints. I'm not sure what's going on. Okay, 2 more slides. Here we go. So x to the, I'm going to do this because I don't think my animations are working. So remember when it's, if it says express using, I have to, if it's a negative fraction, I have to create the fraction. Okay, I'm dropping the x to the 5th power down. Now, let's try number 2. Okay, notice I create the fraction. 5 is not part of the base, only the y. So only y to the 3rd drops down, 5 stays high. It's a whole number. Okay, number 3. Why don't you try the rest? Go. Or I'll do number 3 and then you do the rest. Okay. The whole thing is a negative exponent, so the whole thing drops down, 3m to the negative 2 power, 1 goes up, right? So it becomes 1 over 3 squared, m squared. We take the, oh, it should be when we drop it down at the positive power, which equals 1 over 9m squared. Okay, try 4, 5, and 6. Now let's check our work. Last but not least, we end up with 1 over c squared d squared. Okay, let's go on to, whoops. Now our last one, we're putting it all together, power to a power. First we have to simplify this portion. That's 3 squared. Right? A to the 2nd times the 2nd, b to the 2nd, c to the 3rd times the 2nd. I'm going to just simplify that. That's 9, a to the 4th, b to the 2nd, c to the 6th. Okay, now I'm going to do this times it's supposed to be a times. I'm not, okay. 2 squared, a to the 2nd times the 2nd, b to the 2nd. So that's 4, a to the 4th, b squared. Now, we can multiply unlike terms. We cannot add them. So now this multiplies to 36, 9 times 4. A to the 4th, we're adding the exponents now. So it's a to the 8th, b to the 4th, and c to the 6th. Doing the same thing here. A to the 3rd, b to the 3rd, c to the 6th, times, everything stays the same here. Now we're going to simplify that because we're subtracting. And I'm going to get 5. The coefficient always goes first. Let's keep them in alpha order. A is to the 8th. B is to the 4th. And C is to the 6th. Now, notice this term is exactly like this. So we can substitute it and we get 29, A to the 8th, B to the 4th, C to the 6th. Pause the recording and try the last problem on your own. Now check your work. There we go. And that, my friends, is our lesson.